The Pythagorean identities must be related somehow to a Pythagorean theorem, or they have something to do with Pythagorean or Pythagoras. One way that you can show the Pythagorean theorem is to think about the unit circle. Okay? And if we think about the unit circle, x squared plus y squared equals 1. And we recall, what trig function do we say acts like y, or is y? Sine. And the trig function that is x is cosine. So if I plugged in sine and cosine, I would have cosine theta squared plus sine theta squared equals 1. Now, we usually don't write the power on the outside like this for trig functions. So this is cosine squared theta plus sine squared theta equals 1. You write the power in between the trig function and the angle measure. Alright, this is the first Pythagorean theorem, or Pythagorean identity. We want to think about this kind of like the main Pythagorean identity. Okay, and it probably, if you were looking in a textbook, you wouldn't see cosine squared plus sine squared equals 1. You'd probably see sine squared theta plus cosine squared theta equals 1. Just because that's the way that it's usually, that's the way it's usually written, so that's the way you'll see it in most textbooks. Now, from this first identity, you can get the other two Pythagorean identities that are used commonly. And the way that you get them, you take the first one and you divide the three terms all by sine squared. So if I divided all three terms by sine squared, my first term now is sine squared divided by sine squared. That's 1. My second term is cosine squared theta divided by sine squared theta. And so it's going to be cotangent squared theta. So plus cotangent squared theta equals, and 1 over sine squared theta is going to be cosecant squared theta. Alright, so that is the second Pythagorean identity that is used a lot in trig. Alright, to get the third, we go back to the original. And we divide all three terms now by cosine squared theta. So my first term becomes, this is sine squared theta divided by cosine squared theta. That's tangent squared theta plus cosine squared theta divided by cosine squared theta. That's 1 equals 1 divided by cosine squared theta. That's secant squared theta. So my three Pythagorean identities are sine squared theta plus cosine squared theta equals 1. 1 plus cotangent squared theta equals cosecant squared theta. And tangent squared theta plus 1 equals secant squared theta. These identities could also be used to work out problems like we've previously worked out.